Hello everybody, my name is Tyler Wellington and this is the ArdAlarm, which is my project for the semester, and it is an Arduino security system. The ArdAlarm is a smart security system based off the Arduino that uses Bluetooth communication in order to interact with a partnering Android application. It is a fairly simple system, however it is very effective and functions as a motion sensing security system. My motivation behind this project was the fact that a sense of security is very important, and I think that in recent years, especially, IoT has become increasingly used in the security side of things, and I think that I wanted to make this project to demonstrate that there is a lot of potential for IoT security system devices. So here we have the basic system design of my project. First, the user will end up passing through the sensor, or somebody will pass through the motion sensor of the system, at which case the alarm will be triggered. This will send a signal, quote unquote, back to the user in the form of visual and audible information, which is a message being displayed on an LCD screen as well as a buzzer being sounded. At this point, the user will open up the app on their phone to type in the passcode and send the passcode from the app to the Arduino via Bluetooth. And once that password has been sent via Bluetooth, the system will take it as follows, and if the password is correct, it will disable the alarm. So now looking at the hardware implementation of this system, firstly, we have the Arduino and the modules. This is the main body of the system itself. The program is running on an Arduino Mega 2560 with various modules attached to it. The modules are as follows. First, we have the HC05 Bluetooth module. This module is extremely important for this project as it is what enables the Bluetooth communication between the Arduino and the Android device, or any Bluetooth enabled device, just an Android device in my use case. And it is also what processes the Bluetooth messages coming in so that the Arduino can take said information and handle it as needed down the line. Next, we have the SR04 ultrasonic sensor, which uses sound waves in order to detect distance. It will send out a sound wave and then see how long it takes for that wave to come back and take that time and calculate it into a distance in centimeters. This is important because if it can detect distance, it can detect a change in distance, and thus we use this change in distance as motion to trigger the alarm. Next, we have the LCD display, which can display various messages to the user. This is simply for providing information from the Arduino to the user in a digestible manner. And lastly, we have the piezo buzzer, which simply makes a noise upon the alarm being triggered as a form of letting the user know that the alarm has been sounded. Next, we have the software side of things. For the Arduino implementation, all of the development was done in the Arduino IDE and all of the testing as well. My program uses the following libraries, which go hand in hand with the modules that I've used as well. The software serial library works with the Bluetooth module to create a serial port communication. The new ping library provides a lot of useful tools for the ultrasonic sensor to make converting the time that it takes for the sound wave round trip into distance a lot simpler. The liquid crystal library works with the LCD display to allow simpler programming of displaying messages, and the wire library is a general library that allows me to initialize various objects in my program based on the physical modules that have been plugged into various pins on my Arduino board. And if we look on these images, you'll see some of the source code that has been pulled directly from my program. The bulk of it is the Arduino's loop function, which is the program that is running continuously on repeat while the Arduino is powered on. And what this does is essentially have the Bluetooth module continually scrubbing for data, and anytime it receives a message, it will process it and give it to the Arduino to be able to handle it however it sees fit later down the line. And you'll also see two other methods in the picture on the right hand side, the activate and the deactivate method, which are just two of the simpler methods that show how the Arduino can handle certain signals. Now we will move on to the Android application side of things. The Android application was developed and tested in Android Studio, and it uses the following Android Studio tools. It uses buttons, it uses text fields, and it uses Bluetooth sockets. It uses Bluetooth adapters and Bluetooth device object as well, but those sort of go hand in hand with the Bluetooth sockets in forming the Bluetooth connection. On startup of the app, it will automatically establish a steady Bluetooth connection with the Arduino. This is assuming that the Arduino has been paired via Bluetooth through the Android device's settings prior to opening the app, which it should be. And as long as that is done and the Arduino is powered on and within range, once the application is opened, the device will automatically establish that Bluetooth connection with the Arduino and it is ready to use. Now, once you have the app open, you're presented with several buttons and input fields, which each serve their own functionality. If you look at the image in the middle, you'll see that there's the arm, the disarm, the send code, and the set code buttons. The arm and the disarm buttons, fairly self-explanatory. One sends the signal to arm the system, one sends the signal to disarm the system. The send code and the set code, however, both require text to be input from the user. So before being able to actually push those buttons, you must enter something in the corresponding text field in order to either send a code or set a new passcode. And now I will show you a quick demo of my project. So here is my system all laid out. You'll see we have the Arduino with the various modules hooked up to it, as well as an Android phone with the application on the left. So the default state of the alarm is disarmed. And we will take a look at the app now, and you'll see the various buttons as I've just explained. So now what we will do is we will arm the alarm, and you'll see when I click this arm button here, and I go back to the LCD display, it changes and it now shows the alarm status as armed. And if I come back to the app and I press the disarm button, you'll see I get this disarm successful message, letting me know that the alarm will now be disarmed, and it returns to the disarmed status. So now what we'll do is arm the alarm, trigger it, and attempt to disarm it with the password. So you'll see the alarm has now been alarmed, the alarm has now been armed, and here is the ultrasonic sensor. I will put my hand in front of it, and it will see that the distance has become shortened significantly, and thus it will treat that as motion and trigger the system. So now we get this message: alarm triggered, enter password. So we'll go back to the app. For the sake of testing, the password right now is 1234. I will enter that password, I will hit send code, and when I go back to the screen, you'll see disarm successful. You may have noticed it said incorrect password there for a moment. That's currently a bug I'm working on, but the passcode was correct and the alarm is now disabled. We will now show the set code feature. So here we'll open up this text input file or field, and we will type in a new passcode, which will be WASD. We will send it, and you'll see we get that little pop-up on the bottom saying passcode set to WASD. You'll see that the alarm is currently disarmed, and we will go and do the same thing again. We will arm it. we will trigger it by sticking my hand in front of the sensor's line of sight. We'll get that triggered message and we'll come back to the app and we'll type in the new passcode, WASD, hit send code, and then you will see we get that disarm successful message displayed, and it will return to the disarmed status. And that is how my ArdAlarm works. Thank you very much for watching.